Welcome back to IoT series. In this video, we'll be discussing about identification protocols. We'll look into what semantic protocols are and device management protocols. So all these topics come under the IoT communication technologies. So if you have not subscribed to my channel, if you have not referred the playlist, IoT playlist, I would suggest you to go through those videos first and then get back to this. So let's get started. Firstly, we'll discuss about identification protocols in IoT. So identification protocols are systems or the standards those are designed to uniquely identify and securely identify the devices which are connected over a network. So when you're actually working upon the network deployment in a particular the IoT deployment in a particular network, it is very important to identify these devices, right? And these it is very important to identify these devices, and along with that also perform various operations on it. So for that we'll be making use of these protocols. So these protocols will enable or help us to establish seamless communication, secure authentication, and effective device management in large scale IoT deployments. So basically we'll be discussing about these three protocols. So let's start with the first one, that is EPC, electronic product code. So from exam perspective, EPC and uCode are important ones. So make sure do not miss these. So electronic product code is universal identification system that is designed to provide unique identifiers for all physical objects. That is, for all the objects, in order to uniquely identify it over a particular system or over a particular network, you will be making use of EPC. Okay, so it was developed as an open It was developed as an open standard by EPC Global and is integral to supply chain management and IoT systems. So EPC plays a major role in supply chain management and in the integration of IoT systems. So this provides a robust and scalable identification system, which is very important for modern day applications. So it ensures that physical objects can be identified and tracked globally with precision and efficiency. So we'll look into the key features one by one. First one is unique identification. So every object will be uniquely identified firstly, and there are 3 into 10 to the power 48 objects or uniquely identifiable capabilities which are provided in this particular EPC. So it has a standardized format, that is it is defined by the EPC global tag standard. So the official representation is uniform research identifier, URI, which is referred as the pure identity of URI. Then it has binary and URI encoding. So it supports binary formats for low memory systems like RFID tags, and it provides encoding and decoding rules for seamless interchange between the URIs and binary formats. So it is not just restricted to RFID data carriers, it supports integration with barcodes also. And it has a very flexible framework, that is it can accommodate various identification keys including the GSI application identifier system. Speaking about the structure, so in the structure mainly there will be a header will be of 8 bits. So this will identify the EPC format. Then we have EPC manager. EPC manager is of 28 bits. It will specify what organization or what company the object is belonging. Then we have object class. In this object, what is the category or the class under which it falls. Then we have serial number. Serial number is the unique identification number which is given to that particular object. It is of 36 bits. So this was about the EPC representation. Speaking of applications, supply chain management, retail and IoT systems. Supply chain management, tracking, managing the inventory across global logistics, and in retail to identify the products in using RFID tags and barcodes. IoT systems, linking the physical objects to digital counterparts for seamless integration in smart environments. Moving on further, we have uCode identification system, again a very important topic. So uCode is unique identification system which is designed to tag every real world object and link their digital information. For every real world object, there will be a digital information link that could be achieved by making use of uCode. So it was developed and supported by UID Center in Japan, and it plays a crucial role in Internet of Things by offering universal, application independent and technology agnostic identification. So this is very robust and flexible, and it helps us to integrate with various technologies, various industries, and it plays a very important role in IoT ecosystem. Speaking about the features, it uses 128-bit codes capable of generating 34 into 10 to the power 38 unique codes, and it can tag not only physical objects but also space, places, concepts and digital content. We are making sure that each and every physical entity is being tagged or mapped to a digital information, and that could be achieved through uCode. And it makes use of utron security. So from security perspective, it's very strong, and it can store the information in different tags, RFID tags, acoustic tags, barcodes. There are nearly 6 types of tags. We'll be discussing that. Then pure number representation. So ucodes are making use of the tagged item, and they, by having a pure number, it becomes easy to identify it and ensure universal applicability and avoid any conflicts which are happening. Speaking about the components here, so first component is ucode. Ucode are the different identifiers here. Okay, and then we have ucode tags. Ucode tags are the print tags or the acoustic tags or the active RFID, active infrared, passive RFID tags. Then ubiquitous communication, which happens communicator. So devices like mobile which are used to read these tags are called as ubiquitous communicator. Then ucode resolution center. Ucode resolution center is where the ucode is processed and it provides associated information. In ucode information center, it will store the information or check what information is linked and all. So both these ucode resolution and ucode information are encrypted. So thereby it provides high security. As in, from security perspective, we've spoken about utron, right? So that is what is being implemented here. Speaking of the operational process, a ucode tag is read using a device, that is communicator. Yes, done. And then inquiry is sent to ucode resolution, and via internet the server will fetch the details, and it will be sent to the information source. So ubiquitous communicator will give the detailed content back to the source, right? So speaking of the hierarchy, we have root level, we have top level domain and second level domain. Root level is maintained by the Japan, and top level domain is maintained by Japan and Finland, and second level is, it can be added without any restrictions and enhance the scalability aspect. So print tags means those tags which are printed, like the barcodes, the QR scanners and all. Acoustic means it will happen through sound waves, and active RFID means it can read and write operation, both could be performed. Active infrared is by making use of our infrared rays. And then we have passive, just read operation can be performed on this. So this was all about ucode. Next we have URI, unique resource identifier. URI is a standard protocol which is used to identify different resources through character strings, which will enable global uniqueness. It sets a foundation for web-based resource identification and interaction. Looking at the key characteristics, first one we have is the syntax rules. That is, uniformly it has to be same, right? Globally it has to be same. So there are certain syntax rules. Then it enables extensibility through hierarchical naming schemes. So this naming schemes also will see it. Then we have interaction protocol. So it facilitates the interaction protocol over www. Then types of URIs. First one is uniform resource locator. So it specifies the location of resource and accesses the mechanism further. So it can be referred to as web addresses. For example, www.abc.xz home index. So here the protocol is www. Then the host name is www.abc.xz, and the path or the hierarchy is being specified here. In home, further it is in index. So that's what we have spoken here. The syntax rules, hierarchical naming scheme is followed here. Then we have uniform resource name. So it identifies the resource in specific namespaces. Unlike URLs, URNs do not provide location or access method. So this is, here location was being specified, here location is not specified. If you can check here, it is completely contrasting. Neither the protocol nor the host nor the path is specified here. Here just the ISBN book, like how do we access it, only that detail is being specified here. Okay, representation of URI link, we have protocol here, host, directory and file name. Again we know this, protocol is there, host is there, path is there. Example, we have seen this. Applications are uniquely identified and access resources to internet, integral to web browsing, APIs and IoT systems, and it serves as base for URLs and URNs, enable various resource management methods or techniques. Identification protocols, we have discussed 3 protocols here. Now let's look into the device management protocols. So as we know that IoT devices are growing rapidly. So it is very important to manage these devices and make sure that they are performing whatever operation they have properly. So in order to do that, we'll be making use of these protocols. So these protocols will have centralized control. It will enable monitoring and configuration of these IoT devices. Under these, we have 2 well-known device management protocols. We'll look into them one by one. So the first one which we'll encounter is the TR-069, that is CPE WAN Management Protocol. So TR-069 is a key protocol which is designed for remote management and auto configuration of customer premises equipment, CPE. That's why CPE is here. Like routers, gateways, and set-top boxes over IP networks. It is used in managing devices that are connected through internet, and it will facilitate functions like software updates, diagnostics, and configuration also. So this protocol was defined by the Broadband Forum. It utilizes the CPE WAN Management Protocol (CWMP) to enable communication and management between the CPE devices and auto configuration servers. Speaking about the set-top boxes and gateways, that's how it gets updated. Software updates and configuration happens automatically here. So it is very crucial for automating the management and configuration of IoT devices. So it simplifies the process for service providers by allowing them to remotely configure, diagnose, and manage their devices, thereby reducing the cost of on-demand maintenance. So if the device is required on-demand maintenance, then the person has to the serviceman has to visit each and every time and perform the operation, perform the updates, right? So by making use of this protocol, all that is or we can overcome all such things. So it is very secure and flexible, and it is a reliable choice for service providers managing large key network of devices. So let's look into the key features. First one is customer premises equipment. So customer premises equipments are devices which are located in the customer premises. So they require remote configuration such as broadband routers or VoIP devices. So these devices or routers have to be such a way that they can be auto configured. So even if I'm sitting at my office, I should be capable to auto configure or perform various operations over your set-top box which is present at your home. In order to achieve that, we'll be making use of customer premises equipments. Then we have ACS, that is auto configuration server. So this server will manage and configure the devices remotely. So it can communicate with multiple devices at once, because multiple devices need to be updated over a town, right? Multiple set-top boxes have to be updated if a new channel is being added in TV, right? So CWMP, that is CPE WAN Management Protocol, this protocol is used between the ACS and CPE devices. It is bi-directional both the ways, and it is based on SOAP, Simple Object Access Protocol, and HTTP and HTTPS. Next, functionalities. So communication protocols. So we make use of SOAP or HTTP for communication purpose, and then bidirectional messaging is happening. Session management is there. So each and every transaction or each and every session will begin with inform message, which is sent to the CPE to notify that ACE's presence. Then ACE will inform response in order to acknowledge, telling that I'm ready. Update can happen accordingly. Then device configuration, that is provisioning sessions. So sessions will be there to set up and configure the device for update process, and after the update is done, transfer complete messages depicted. From security perspective, HTTPS encryption is there. Security perspective, S secured. And speaking of the authentication, devices are authenticated using a secret shared key, which ensures secure communication and data exchange. That is, symmetric encryption is happening here. Then speaking of the timed out sessions, there is typical time limit which is present, and if anything, if the transaction or the session goes or exceeds beyond this time limit, then that transaction is ended then and there. So looking at this figure here, which speaks about the various components, we have CPE components which will communicate with the ACS for provision and management. Then we have ACS which will respond with the configuration, instructions and management data. Then CPE will execute the commands and return back to the ACS. Then next protocol which we have is OMA-DM, that is Open Mobile Alliance Device Management. So this is designed for remote management of mobile devices like phones and tablets. So it is specified by Open Mobile Alliance working groups. So it mainly focuses on device management and data synchronization. Main goal is to make sure that our mobiles or laptops are working properly, even if there is little memory, limited storage and processing power. Their operations are happening properly in a given IoT environment. First feature is remote management. So it will support to manage these devices remotely, perform configuration, software updates, fault management, and all of that. And the protocol can handle both wired and wireless updates and communications. Then you have constrained devices, those devices which have less memory, less storage, and less capabilities. Even those devices can work under this particular protocol. And the data exchange is happening by using SyncML, which is a subset of XML protocol. from communication model, it makes use of request response communication model. So before each time when your mobile has to get updated, there's a drop down message which is present. So only when you say agree, that's when the upgrade process starts in your mobile, right? So that's what the request response is happening here. Then looking at the communication flow, first is the client server interaction. The interaction happens between the mobile device and the server, and if the messages are large, then it is broken into chunks. Then asynchronous communication is happening, that is server will send the message at any time, and the client is expected to execute the command and reply with the indicating the outcome. So your notifications or alerts can be sent over the software changes and required actions. Speaking from the security and authentication perspective, OMA-DM will ensure that security by authentication mechanism to prevent any of the malpractices. So devices and services must authenticate with each other before actually sharing the data with each other. So here the again session key exchange can happen here. So looking at this figure, which will explain us about the communication between OMA-DM client and a server. So here we have the client, which will comprise of all the resources and parameters. Here client could be the mobile phone also. Here we have a device specific interface. So the interface on which we will get the request and response message tree here, and followed by that we have DM server here, where the actual communication or any in order to start the communication, the messages are sent from here and accordingly. So OMA-DM serves as a command to the client. So the client executes the command and responds with acknowledgement or status update. So the exchange happens over transport layer protocols, that is WAP, HTTP, OBEX, depending on the available network. Next, we have semantic protocols. So semantic protocols will tell us how to handle the meaning and logic behind the data which is being exchanged in our IoT environment. So unlike the communication protocols that focus on the format and structure of data, semantic protocols will tell us or make us understand about how devices and systems will interpret this data, and it will tell us what are the meaningful ways how to deduce content from that data. This will also tell us about the cross compatibility and more efficient integration with many different IoT systems. So the first one which we have, the protocol which we have is JSON-LD, that is JavaScript object notation for linked data. So JSON-LD is a lightweight data interchange format which is used to convert the data from one format to another format depending on the machine or human readable language. So it is based on JavaScript object notation, and by adding support for linked data, it becomes a particular whole protocol. So it will provide seamless linking and interlinking of resources over the web. So looking at the key features, first one is contextual data representation. That is, the data is embedded within the data, which will help us to define the meaning of each property which is specified inside the data. So the context is defined using @context keyword, which will help us to understand properly, right? Then we have RDF, that is resource description framework compatibility. So JSON-LD will integrate with RDF, which is a framework which will help us to understand what is the relationship between these resources over the internet. So it will make us easy to understand how the data is being linked and what are the different domains which are present here and how the understanding is being established. Then we have interoperability, which by using the fixed ontology and linking data through the predefined groups, this protocol will allow interoperability between different systems, making it easy to share the data and integrate across various platforms. Then we have linked data. So linked data are created by connecting pieces of data over the internet. So by starting with a single piece of data and adding data, machine can traverse through each of those, like there are embedded links here, right, and discover the or retrieve the information from these linked data. Like there is flexibility in embedding context. That is, context can be embedded directly with the JSON-LD document or referenced via external file using HTTP link headers. So this will provide flexibility in how the data is structured and how it is actually shared from the human understandable format to the machine understandable format. So if you look at this figure, it speaks about a sample JSON-LD schema. So again, here we have @ will tell us like typically a URL, the link of data to a vocabulary or ontology. In this case, it is schema.org. Then we have @type, which will define the type of entity. It could be blog posting, web page, person. Here it is web page, right? Then speaking of the link properties, main entity of page will represent the link like a link to the web page that the blog that particular blog will belong to. Then you have image, which will specify an image which is related to that blog. The size would be specified. Author and publisher will define the entities responsible for that content, and date published is when did I publish it. Benefits are human readable. So because it is JSON format, it is easy for us to understand and perform various operations. Interoperability, by supporting RDF, it makes sure that the data can be shared and understood across different domains and different platforms. And integration with semantic web, so it will help us to integrate with the semantic web, adding context and meaning to data. Thereby, better data discovery and interoperability is achieved. Then we have RESTful environments. So this is well suitable for RESTful APIs, which is a very popular choice for IoT applications, right? So yeah, next protocol which we have is WebThing model. So the WebThing model is core component of Web of Things initiative, which was designed to make sure that the IoT devices, all the IoT devices are capable to connect to the web. So this system provides web-based technologies, and it provides a structured way for devices to interact over the internet using uniform protocols, data models, and resources. Looking at the key concepts, first is we have web things. Web things are, it could be devices, systems which are which could be accessed and controlled through internet or web. So they are usually represented as web resources, and we make use of uniform resource locators to locate them for identification and interaction purpose. A web thing will act like a web server, which will allow communication between different web resources. Speaking about the integration patterns, either it could be direct integration between the devices and the web, or it could be a gateway based. There are multiple web devices, there are multiple web resources here, provided that there is a gateway, and this gateway will make sure that there is proper routing happening from these devices to the web or internet here. Then we have cloud based, so directly communicating to cloud, allowing remote access and control via internet based services. Speaking of the requirements, so there are guidelines on to how web things should behave to ensure smooth interaction and interoperability within the web of things. This will include limitations of IoT devices like limited memory, processing power, and we have to make sure that there is usage of standard protocols are supported. That's when web of things can work properly. So this model will specify web things that there are certain constraints which need to be considered in order to effectively execute the functioning. Then we have data exchange over WOT. So in WOT, data is exchanged using the RESTful protocols. Then we have structuring of data, which will help us to transfer the data properly, consistently, scalable and understandable format. And not just that, ensuring the context awareness so that IoT devices can provide meaningful information again plays a very important role while dealing about the data exchange format. So the extended web of things EWOT model further extends whatever is present here WTM model, which will have extra features like enhanced data models, ability to support richer and more complex interactions. Speaking of the RESTful web protocol, this protocol is built upon the REST, that is representational state transfer. We have studied, if you have not watched previous video, we have discussed about REST protocol. So I would suggest you to check all the videos in the IoT playlist, and yeah, stay tuned. So RESTful protocols will allow IoT devices to connect easily, accessible to each other, and we make use of HTTP methods here to perform various operations on the device resources. Then we have payload syntax and data models. Payload syntax will tell us how the data should be formatted when it is being exchanged from the devices to the web. So this web thing model will make use of standard formats, like here it is JSON. So to represent the data, which is easily understood by humans and machines as well. The data models are in like predefined structures which will define the types of resources that a web thing can access. So there could be a standard, common standard, which has to be followed by everyone. Looking at the benefits, first one is interoperability. So because we have standard protocols, data models, it becomes very easy for different manufacturers and platforms to work together. Scalability is RESTful web protocols we have, so multiple devices, multiple resources can be connected. Simplicity is it is very simple to integrate, connect and perform various operations. Speaking about the context awareness, by incorporating the context and communication between the devices and systems, it becomes very easy to transfer the data, and intelligent and dynamic interactions can happen depending on the changing conditions. So this was about the semantic protocols. We have covered all the important topics, all the major protocols in this video. If you have any doubts, do let me know in the comments, and stay tuned to my channel. Thank you.